Hello everyone, welcome back. Today we will be entering chapter 14, which is the last chapter for this whole semester. So it is on thermodynamics. There is 3 subtopics in this chapter, and the first subtopic is on first law of thermodynamics. So there's 3 laws of thermodynamics, but in our matriculation level, we only will be learning on the first law of thermodynamics lah. Okay, so the first subtopic, you should be able to state the first law of thermodynamics and then solve problems related to the first law of thermodynamics. Okay, so first law of thermodynamics states that the heat supplied to a system will be equal to the increase in the internal energy of the system plus the work done by the system on its surroundings. Okay, so mathematically we can write it as Q equal to delta U plus W. Okay, where Q is the heat supplied, delta U is the change in internal energy, and W is the work done. Okay, so basically yang delta U ni just U2 minus U1 lah. Okay, final minus initial. Right, so we have sign convention for both heat and work, so make sure you are able to remember the which one yang will be positive and which one will be negative. Okay, right, so heat will be positive when heat is flowing into the system. When heat is flowing into the system, heat will be positive. When it is flowing out of the system, it will be negative. And then for work done pula, if the work is done by the system, the work will be positive. If it is work on the system, it will be negative. Right? Excuse me, sorry. Okay, so for example, the work done by the system and on the system is shown in this figure here. So when the air is expanded, so when the piston is going up, the molecule will lose kinetic energy. Hence, it will do a positive work on the piston. Okay, meaning that this is when the work is done by the system. Okay, and then if the air is compressed as the one shown here, the molecule will gain kinetic energy and thus negative work on the piston, meaning the system is having work done on it. Okay, right, so the first law of thermodynamics is actually a generalization of the principle of conservation of energy. It basically needs to include the energy transfer through heat as well as mechanical work. Okay, so the change in internal energy of a system is independent of path. Okay, so for example, if a thermodynamic system can go from state 1 to state 2 as shown in this figure here lah. Okay, the internal energy depends only on the temperature of the system. Okay, so if the initial and final temperature is the same, the internal energy will be equal to 0. Okay, internal energy formula there is similar to the one in chapter 13, which is our previous chapter lah. Okay, so if there is no change in temperature, the internal energy will be 0 lah. Okay, so U2 will be equal to U1. Okay, so basically internal energy does not depend on the volume does not depend on the volume of the system. It is, however, depends on the temperature of the system lah. Okay, also the change in internal energy will also be 0 if the cyclic thermodynamic process Okay, so if the initial and final state of the system is the same, the change in internal energy will be equal to 0. That is right. Okay, so basically what you need to know in this part of the theory is first law of thermodynamics is basically this one, or you can also write in words, and then you also should be able to memorize sign convention for both heat and work done. Okay, if the air is expanded, work is done by the system. If the air is compressed, work is done on the system lah. Okay, so that is basically what you need to know in this theory part. Next, we will be solving problems related to the first law of thermodynamics.